Lesson 9, I will multiply 3 and 4-digit numbers applying the standard algorithm. So in your Zern lesson, you learned how you can go from partial products to standard algorithm, and that's what we're going to practice in this lesson as well. All right, so go ahead and get out your problem set and make sure that you write your name at the top, and we're going to start with some partial products. All right, so we've been transitioning away from the place value chart to partial products. So if we have 4 ones times 4, that would be 16 ones. This is what we've been working on. And then if I have 3 tens times 4, that's going to be 12 tens, which is the same thing as 120. And then I'm going to add these two together. All right, so again, this is just a review. This is not anything new. So I have 136. Now I'm going to solve this same problem using standard algorithm. So I still have 4 ones times 4. But instead of writing 16, I'm going to kind of do this like when I do addition. I'm going to go ahead and put the ones, and I'm going to carry, or I'm going to regroup, or I'm going to bundle the 10 ones, and I'm going to put it right here to make it a 10. Now I have 3 tens times 4, which is still 120, or 12 tens. But I'm going to go ahead and add this 10 too. So now instead of 3 times 4, which is 12 tens, I'm going to have 13 tens. I'm going to go ahead and mark this out to show that I used it. So I have 13, so I have 136. Okay, now what you can notice here is that whenever you do standard algorithm, the difference between this partial products and this standard algorithm are not really that much difference. This really wasn't a whole lot faster, but when you start adding digits to standard algorithm, you can see that it can start to be a whole lot more efficient, meaning you can do it a little bit quicker. All right, so I would like for you to do B using partial products all by yourself, and then let's come back and check together. Okay. So let's check your partial products. So hopefully you start with 4 times 3, which will give you 12 ones, 2 tens times 3, which is 6 tens, and then 2 hundredths times 3, which is 6 hundredths, and then when you add all of your partial products together, you get a product of 672. Now let's do this same problem using standard algorithm. So we still have 4 ones times 3, which is 12. So I'm going to put my 2 ones and my 1 10 in the tens place. Now I have 2 tens times 3, which is 6 tens, plus this 10, which makes 7 tens. Now I have 2 hundredths times 3, which is 600. So you can see I've got 672 here and 672 here. So we're transitioning away from partial products to standard algorithm because this is more efficient. We can do this using less space and a little bit quicker. All right, so now we're just going to do standard algorithm. We're going to do one together, and then I'm going to let you try some by yourself. If you feel like you can go ahead and do this by yourself, go ahead and pause the video and do all 6 of these by yourself, and you can come back and check. But if you'd like to do this one with me, just stay with me and I'll walk you through this one. 1 1 times 3 is 3 ones. 5 tens times 3 is 15 tens. So I'm going to carry the 1 10 into the hundreds place and put my 5 in the tens place. Now I have 2 hundredths times 3, which is 6 hundredths, plus 100 makes 753. All right, I'd like for you to try B and C by yourself. If you get stuck, it's okay. Go ahead and press play, and I'll walk you through it, but I want you to try to do it all by yourself. Okay, so hopefully you try to do B all by yourself. Let's take a look at the ones place. So I've got 5 ones times 6, which is equal to 30. So I've got 0 in the ones place, and then you can see right here that I carried my 3 tens to make 30. Now I've got 3 tens times 6, which is equal to 18 tens. I took my 18 tens plus 3, which gave me 21 tens. And then I took 100 times 6, which is 6 hundredths, plus these 2 hundredths gave me 810. All right, let's take a look at C. All right, so I did the same thing here. I started here with my 4 ones times 9, which gave me 36. So you can see here that I put my 3 ones, or excuse me, my 3 tens are 36 ones. 0 9 times is 0 tens plus 3, which gave me 3 tens, and 3 hundredths times 9 gave me 27 hundredths, or 2,736. All right, I'd like for you to try to do D, E, and F all by yourself, and then let's come back and check together. Okay, so hopefully you tried to do these three problems by yourself. If you got stuck, that's okay. Hopefully I can explain it to you a little bit to help you to understand a little bit better. All right, so let's start with 5 ones times 4 is going to give me 21s. So you can see I carried my 2, and here's my 0 for my 21s. 0 tens times 4 is 0 tens, plus 2 tens gives me 2 tens. 4 hundreds times 4 gives me 16 hundredths. All right, let's take a look at E. So I've got 6 ones times 5, which gives me 30 ones. 110 times 5 is 5 tens, plus 3 tens gives me 8 tens, and 3 hundredths times 5 gives me 15 hundredths. All right, let's take a look at F. Now I have 2 ones times 6, which gives me 12 ones. 9 tens times 6, which is 54 tens, plus 1 gives me 55 tens. And then 3 hundredths times 6 gives me 18 hundredths, plus 5 gave me 23 hundredths. So I have 2,352. All right, now we're going to use our standard algorithm to solve a couple of problems. You can see here that I have the product of 7 and 86 is. So product means I'm going to be multiplying. So I'm going to multiply 86 times 7. I'd like for you to go ahead and solve this using standard algorithm, and then we'll come back and check together. Okay, so we have 6 ones times 7, which is going to give us 42 ones, and then 8 tens times 7, which is 56 tens, plus 4, which is going to give us 60 tens, which is 602. I'd like for you to do 4 all by yourself, and then let's come back and check together. Okay, so hopefully you recognized 9 times as many as 457 to be 457 times 9. So we've got 7 ones times 9, which is going to give me 63 ones. 5 tens times 9, which is going to give me 45 tens, plus 6, which gives me 51 tens. And then 4 times 9, which is 36, plus 5, which is going to give me 41 tens, which is 4,113. All right, let's take a look at an application problem here. So I see already that I have words, so that tells me that I'm going to read, I'm going to draw, I'm going to write a number sentence, and I'm going to write a word sentence. So let's read this. Jashawn wants to make 5 airplane propellers. He needs 18 centimeters of wood for each propeller. How many centimeters of wood will he use? So it looks like I'm going to have 5 18 centimeters. So I'm going to go ahead and draw my I'm going to go and draw my tape diagram here. And this is going to represent the total amount of wood that he's going to need. So since he's got 5 airplane propellers, I'm going to divide this into 5 parts. And since he needs 18 centimeters for each propeller, I'm going to put 18 in each of these. So you can see here I've got 18 5 times. So I want to know what the total is. So I'm going to go ahead and put a W for my unknown. That's what I'm trying to figure out. What is all this together? So I could add 18 5 times, or I could do standard algorithm 18 times 5. I'd like for you to go ahead and solve this. This is our number sentence. We drew, we read. I want you to solve this, and then I want you to write your answer as a statement, and then we'll come back and check together. Okay, so when I did 18 times 5, I knew this was 8 ones times 5, which gave me 40 ones. And then 110 times 5 is 5 tens plus 4 tens, which is 9 tens, or 90. So then I went ahead and answered this question. How many centimeters of wood will he use? And I wrote, he will use 90 centimeters of wood. All right, let's take a look at number 6. All right, so we're going to read, we're going to draw, we're going to write a number sentence, and we're going to write a word sentence. One game system cost $238. How much will 4 game systems cost? I'd like for you to go ahead and draw a tape diagram. I want you to write a number sentence, and I want you to write a word sentence to solve this problem. If you get stuck, you can always press play, and I'll walk you through it, but I want you to try to do this all by yourself. Okay, so we already read the problem. Then it was time for us to draw. So I knew I had 4 game systems. So when I drew my tape diagram, I divided it into 4 sections. Each section was worth $238, and my total was what I was trying to figure out. So I could have added 238 4 times, or I could have said 238 times 4. And then when I solved using standard algorithm, that gave me 952. So then I answered the question, how much will 4 game systems cost? 4 game systems cost $952. All right, now let's take a look at number 7. A small bag of chips weighs 48 grams. A large bag of chips weighs 3 times as much as a small bag. How much will 7 large bags of chips cost? All right, I want you to take a look at this. This is a 2-step problem. If you feel like you understand what to do, go ahead and solve this problem by yourself. You can pause the video. If you'd like for me to walk you through the setup of this problem, I'll be glad to. All right, so we read the problem once. Now I will tell you, I'll have to go back and read this again so that I can help myself know what to draw. So first of all, I'm hearing some comparison words. A large bag of chips weighs 3 times as much. So I think I'm going to go ahead and set this up into 2 tape diagrams. I'm going to start with my small bag of chips, and that's 48 grams. So I'm just going to go ahead and draw 48 in this one box. It says that a large bag of chips weighs 3 times as much. So if it's 3 times as much, that means that it's going to be 48 3 times. Now notice this tape diagram. I tried to make this where it was 3 of the small bags. Now it's not perfect, but at least you can tell that I tried to make it look like it was 3 of the small one. Now the question doesn't ask how much is this all together. The question says how much will 7 large bags of chips weigh? So this is a 2-step problem. All right, first of all, I've got to figure out how much 1 large bag of chips weighs. So this is what I'm trying to figure out here. 48 3 times. So I'm going to go over here and I'm going to solve this using standard algorithm. 48 times 3. So let's go ahead and solve this together. 8 ones times 3 is going to give me 24 ones. And then I've got 4 tens times 3, which is 12 tens, plus 2, which is 14 tens. So I've got 144 grams for 1 large bag of chips, but that's not what it's asking. It says how much will 7 large bags of chips weigh. So the next step is going to be to take 144 7 times. I want you to go ahead and solve this problem using standard algorithm. We've already written 2 number sentences. Then I want you to write your answer as a statement, and then we'll come back and check together. Okay, so let's take a look here. So I did 4 ones times 7, which gave me 28 ones. You can see my 28. And then I did 4 tens times 7, which is 28 tens, plus 2 tens, which is 30 tens. And then 100 times 7, which is 7 hundreds, plus 3, which gave me 10 hundredths. So I got an answer of 1,008. So how much will 7 large bags of chips weigh? 7 large bags of chips weigh 1,008 grams. All right, so that is the end of your problem set. So I hope that you got lots of practice today using standard algorithm. It will take you lots of practice to get really good at this because you're kind of multiplying and adding at the same time, but stick with it and you will become fluent at using the standard multiplication algorithm.